Hello, students. I am here to talk to you about the mole. Right here, it's this furry little guy, but it's also this happy little number. The mole is the SI unit for counting by measuring. It means small piles. It can be abbreviated MOL, not M. Remember, this is meters, and it's just a counting unit. It's just like a dozen, except for it works with lots and lots of particles. So let's think about a dozen and see how that works. A dozen donuts is always 12 donuts. A dozen books is always 12 books, and a dozen cars is always 12 cars. All right, so we know what a dozen is. Why don't we just use dozens? Well, the problem is that atoms and molecules are extremely small. In fact, they're so small that 12-ounce bottle of water, 355 milliliters, would have 1.19 times 10 to the 25th molecules of water. That's a lot. Remember, times 10 to the 23rd is sextillion. That's 25 zeros. So we do this math, and we have 1.19 times 10 to the 25th molecules. We know 1 dozen is 12 molecules. Again, our happy little dimensional analysis here, our happy little unit conversion. And so we still have 9.89 times 10 to the 23rd. This is 9.89 sextillion. This is no better. So it's that many dozen. Why would we use that? In fact, we'll use something better. We'll use a mole. We'll use Avogadro's number. 1 mole is 6.022 times 10 to the 23rd. That works out well. We see, wowzer, wowzer, that's a lot of zeros. But it's the same sort of thing. 1 mole of donuts is 6.02 times 10 to the 23rd donuts. 1 mole of atoms is 6.02 times 10 to the 23rd atoms. And 1 mole of molecules is 6.02 times 10 to the 23rd molecules. All right, Mr. Chamberlain, you've got this number. You like this number. Why the heck would we use this number? That's because now a 12-ounce bottle of water, instead of having 12 ounces or 1.19 or times 10 to the 23rd dozens, now we have 19.7 moles of water. This is a nice number. I can work with 19.7. I don't want to work with crazy scientific notation. So we work with this. It's much easier for chemists to work with. So we look here. I can show that 1.19 times 10 to the 25th molecules times 1 mole over 6.02 times 10 to the 23rd molecules gives us 19.8 moles. This is great. So what's it look like? So it varies depending on the substance. You saw some of these earlier. We saw a petri dish full of sulfur, zinc, sodium chloride, even though it was coming out. It would be similar for iron. Water is 18.01 ml, so half a small beaker of water. Or lactose. We could do a mole of lactose. That's a sugar. And when we're working with small particles, it's always the same. It's always going to be Avogadro's number. But we'll talk about different small particles for different things. Elements have atoms in them. Ionic compounds, we haven't really talked about this before, has formula units. Molecular compounds have molecules in them, like water. Sodium chloride would have formula units. And then if we're just talking about cations or anions like sodium itself, when it's ionized, would just be ions. So a mole is going to be in that many mole of copper, sodium chloride, H2O, or nitrate ions is always 6.02 times 10 to the 23rd atoms, 6.02 times 10 to the 23rd formula units, 6.02 times 10 to the 23rd molecules, or 6.02 times 10 to the 23rd ions. So, moles, when we're talking about atoms, are very small. Like we said, we could fit it into a fit it into a petri dish. But if we're talking about things that are regular size, a mole of hockey pucks would equal the mass of the moon. A mole of basketballs fill a bag the size of the Earth. A mole of pennies would cover the Earth 1/4 mile deep. And a mole of seconds is 4 million times as long as the Earth has even existed. So a mole is a lot. Let's do an example. I want you guys to know how to do this so you can do the Moodle quizzes, so you can understand this, so we can predict what's going to happen in reactions. That's what we're getting, guys, but first we need to understand how to do this. So 1.25 moles of water we want to convert to molecules. So what do? Unit conversion. You guys are going to be great at this. So 1 mole of water is going to go on the bottom because we want it to cross out. Cross out, cross out. And it's 6.02. It's Avogadro's number, number of molecules. We multiply 1.25 times 6.02. That gives us 7.53, and we bring over the 10 to the 23rd. Now, remember, if it was 75, we would have to convert it proper scientific notation. So let's do another example. Opposite direction. How many moles are equal to 2.8 times 10 to the 22nd molecules of water? Let's do that. We have molecules. Those are our first units. We're going to move to different units. So let's do unit conversion. Our conversion factor is 1 mole is 6.02 times 10 to the 23rd molecules. And we have molecules in the bottom, moles up top, because we want them to cross out and we want to end up with moles at the end. So we have 6.02 times 10 to the 23rd molecules. We multiply 2.8 times 1. That does nothing. We divide by 6.02, and we have 10 to the 22nd divided by 10 to the 23rd. So we're going to subtract, and we're going to get 0.0047 moles of H2O. So here's an extra credit problem for you. On clean notebook paper, bring this one in. How many formula units are equal to 12.62 moles? Bring it in, show me, and you will get an extra credit point. Hope you enjoyed it. See you guys soon.